Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from October November 2023, Paper 1, Variant 1. In today's lesson, our main focus will be on waves. We will discuss all waves questions from this paper. As always we do, we will discuss these questions in detail so you can improve your conceptual understanding of this topic, and also you can have better understanding of these exam questions. Let's study together, let's improve together. Question 20 says two waves pass through a point P. The graph shows the variation with time t of the displacement s of the two waves at point P. What is the phase difference between the two waves at point P? So we have two waves. First of all, we need to check, do they have the same time period or not? If you look at this wave, this has time period of 8 seconds, and if you look at this wave, this also has time period of 8 seconds. So they have the same time period, so we can find out the phase difference. And also we need to understand the ratio between the time difference delta t divided by time period. This is equal to phase difference divided by 360 degrees. So we need to find out, for this question we need to find out phase difference. So the phase difference simply will be equal to 360 degrees times time difference divided by time period. So we need to find out time difference. So to find time difference, we have to take 2 points, same points on two waves. So let's say we take this peak of one wave, so we also need to take the peak of another wave. So you can see what is the time difference between these two. I hope you will simply say this time difference is equal to 1 second. So delta t is equal to 1 second. Now simply we can plug in values. So we have 360 degrees times 1 second divided by time period, that is equal to 8 seconds. Now if we solve this one, we will get 45 degrees. So the answer for this question is B. So this is how you can figure out. This formula you can also extend to path difference. So this ratio is also to path difference divided by lambda. So sometimes they will give you the time difference, they will ask you to calculate path difference, sometimes they will ask you to calculate phase difference. So this is the main idea. Question can be different, but concept is the same, because this is just like a tool. This tool is the same. They can be different machines, but you can different machine, there can be different question, but you can use the same tool. So this is the main tool. Question 21 says which row is correct for both progressive transverse waves and progressive longitudinal waves? If you look at given options, first option says contains compressions and rarefactions. No, transverse waves, they do not contain compression and rarefaction. This is property of longitudinal waves. Some can travel in vacuum. No, longitudinal waves cannot travel through vacuum. So this is property of longitudinal waves and this is property of transverse waves. So option A is not correct. Now if you look at option B, transverse waves can be polarized. Yes, this is right. Contains compression and rarefaction. This is also correct. So the answer for this question has to be B. Option C says vibrations are perpendicular to direction of travel of the wave energy. This is true for transverse waves. Can be polarized? No. Longitudinal waves, they just vibrate in one plane, so they cannot be polarized. Some can travel in vacuum. This is correct. Like electromagnetic waves. Electromagnetic waves are transverse waves, so they can travel through vacuum. So this is true. Vibrations are perpendicular. No, this is incorrect. Vibrations are parallel. So this is incorrect. So this is also not possible answer. This is also not possible answer. So the answer for this question is B. A nice question about properties of longitudinal and transverse waves. Question 22 says a toy drone emits a sound of constant frequency 800 Hz. The speed of the sound in the air is 330 meters per second. The drone moves along a straight path directly towards an observer and then continues in a straight line directly away from the observer. The speed of the drone is constant. What is the velocity of the drone when the frequency of the sound heard by the observer is 850 Hz? So this is quite straightforward question if concepts about Doppler effect are very clear. So what is the first thing we need to do? We need to look at given frequencies. Frequency of the source is given to us. So this is 800 Hertz. And observed frequency is also given to us, that is equal to 850 Hertz. As in this case, observed frequency is greater than frequency of the sound produced by the source. It simply means that source is approaching. So this is the first thing we can infer from the given data. Now if you look at given options, it means option A is not possible. This is moving away, so this is incorrect. This is also incorrect. So we can eliminate option A and B. So in the exam, quickly, if you look at these frequencies, you can find out source is approaching. So you can quickly eliminate A and B. Now answer can be C or answer can be D. Now simply we have to use the formula for approaching source. So we can write down observed frequency. This will be equal to speed of the wave over speed of the wave minus speed of the source and multiply with frequency of the source. For this question, we need to find out speed of the source. So if we cross multiply, we will get here speed of the wave minus we have speed of the source times observed frequency. This will be equal to speed of the wave times frequency of the source. We need to find out, in this case, Vs. So we can further rearrange. We can write down speed of the wave minus speed of the source. This will be equal to speed of the wave times we have Fs divided by F naught. We need to find out Vs. So simply we can write down here now the Vs. So Vs will be equal to V speed of the wave minus speed of the wave times we have Fs divided by F naught. Now simply plug in values, you will get Vs is equal to 19 meters per second. So the answer for this question is C. So this is how you can figure out. Speed of wave is given, so this is the speed of wave. Let me highlight, this is speed of the wave. So we have speed of the wave, we have Fs, we have F naught. Simply plug in, this is the final answer. Question 23 says which statement about electromagnetic waves in a vacuum is correct? This question is about electromagnetic spectrum. Every paper, every year has one question about electromagnetic spectrum in paper 1. So it's very important that you remember electromagnetic spectrum. You need to understand the order of electromagnetic waves. You need to remember the wavelength of electromagnetic waves. And all electromagnetic waves, they have the same speed in vacuum. So you can calculate the frequency. Now if you look at these given options, option A says infrared waves have shorter wavelength than visible light. This is incorrect. They have longer wavelength, so this has to be longer. So it means option A is incorrect. Microwaves have longer wavelength than radio waves. Microwaves, they have higher frequency, but they have shorter wavelength. So it means option B is also incorrect. Ultraviolet waves have higher frequencies than visible light waves. Yes, this is true. So answer for this question has to be C. Gamma rays have lower frequencies than X-rays. Gamma rays, they have higher frequencies. So this is also incorrect. So they have higher frequencies. So for this question, you need to remember electromagnetic spectrum. So this is also incorrect, B is also incorrect. So simply you need to understand Granny's Xbox. So let me write on here. Granny's Xbox use volts in my room. In my room. So with this one sentence, you can remember the order of EM waves. So G is representing gamma. These are gamma waves, you can say gamma radiations. X is representing X-rays here, and U is for UV light, V for visible light, and I for infrared. So this is for infrared, M for microwaves, and R for radio. So this is the order, and I hope you are very clear about this one. If we go from gamma to radio, wavelength is increasing, so we will say wavelength, this is increasing. But if we go from radio to gamma, you need to understand frequency is increasing. So frequency increases and energy is equal to HF. So it means that energy also increases if you go in this direction. Question 24 says vertically polarized microwaves are emitted from a source. The microwaves are detected by a receiver that is connected to a CRO. The waveform displayed on the screen of the CRO has an amplitude of 2.6 centimeters. A matter wire grid that acts as a polarizing filter is now placed between the source and the receiver. The filter is oriented so that the plane of polarization of the transmitted wave is at an angle of 20 degrees to the vertical. The distance between the source and the receiver is unchanged. The settings on the CRO are also unchanged. What is now the amplitude of the waveform displayed on the screen of the CRO? So for this question we have A naught, means initial value of amplitude is given to us, and we need to find out new value of amplitude. A new, simply we need to find out. So for this question simply we have to use Malice's law. According to Malice's law, I transmitted, this is equal to I incident times cosine square of theta. This is the angle between light and transmission axis. But we also understand that intensity is equal to K times A square. Now simply we can replace this I, so we can say it will be new amplitude square times K, and this will be K A naught square time cosine square of theta. Theta is the angle between light and transmission axis, or we can say polarizing filter, axis of polarizing filter. Now K we can cancel from here. We need to find out A new. So this will be equal to A naught square cosine square of theta. We have to take square root of this side. Now from here we can get the final value of A naught. A new, A naught is 2.6 centimeters, so we can use this is 2.6 square, and cos of angle is 20 degrees, so we have cosine of 20 degrees square, and we need to take the root of this, and our final answer in this case will be 2.4 centimeters. So this is the final answer, and this is how you can figure out. So simply you have to use Malice's law, and the second thing you need to understand is intensity is equal to K times A square. So these two things you need to understand, and then you can figure out the answer for this question. So the answer for this question has to be D. Question 25 says, in an experiment, a stationary wave is formed on a string stretched horizontally between two fixed points. Which statement about this experiment is correct? This question is just about stationary waves. You need to understand some basic characteristics of stationary waves. Let's try to understand some basic characteristics of stationary waves. this point is node, this point is also node, and this point is the anti-node. And particles between all the particles between any two consecutive nodes, they are always in phase. But all the particles, they have different amplitude. They have different amplitudes. And also, if I imagine one particle here, after time t/4, this particle will be at this point. And if I take another particle on this string, after time t/4, this particle also will be on this horizontal line. And particle here, after time t/4, this also will be here, and so on. This particle also will be here. Now, if we draw one horizontal line here, so draw this horizontal line here. After time t/4, we will see all the particles on this horizontal line. So this is only for one loop. Now, when we have two loops, what is happening in that case? We can draw first of all this horizontal line here. So this is our equilibrium position. Now we can mark some points here. So let's say particle is at this point. After time t/4, this particle will be here, and particle here after time t/4, this will go down, and this particle will be here, and particle here after time t/4 also will be here. And if you look at this particle, because this particle initially will be moving down, then this particle will be moving up. And after time t/4, this particle also will be at this horizontal line. We can use different color now, will be on this horizontal line. And if particle is here after t/4, it also will be on this horizontal line. And particle here after t/4, this also will be on this horizontal line. All these particles between these two nodes, always they will be in same phase, and particle between these two consecutive nodes, they also will be always in same phase. And all these particles, they will have different amplitudes. And particle in this loop, if I say loop A, mean this loop between these two nodes, and if I say this loop is B, these particles, they will be in antiphase all the time. So these are some basic points we need to understand. If this is clear to you, now if you look at given options, you can easily figure out the answer. If you look at option A, at certain times, the string between two nodes is horizontal with all points having zero displacement. Yes, this is true. We have discussed between two consecutive nodes. At one time, all the particles, they are just lying on this straight horizontal line. So it means option A is true. This option is correct. Each point on the string between two antinodes has an oscillation with the same amplitude. No, each point on the string between two antinodes, mean between this antinode and between this antinode, is telling us on a string each point, no, they have different this has maximum amplitude, this is minimum, and even lower. So here amplitude is equal to 0. So it means this option is incorrect. The number of nodes is equal to the number of antinodes. So if you look at first loop, we have two nodes, but we have one antinode, so it means they are not equal. And if you look at this one, we have 1, 2 and 3 nodes, and we have two antinodes. So number of nodes is greater than number of antinodes. So it means this statement is also incorrect. Not equal. So it has to be not equal. Two adjacent antinodes oscillate in phase. No. Means particle at this point, it will be moving down. Particle will move. They are in antiphase. So this has to be antiphase. So these are the points you need to understand. If you have clear understanding of these points we have discussed for this question, it means you have quite good understanding of stationary waves. Question 26 says, a musical organ produces notes by blowing air into a set of pipes that are open at one end and closed at the other. The speed of sound in the air in the pipes is 320 meters per second. What is the lowest frequency of sound produced by a pipe of length 10 meters? Lowest frequency. So it is given to us one end open and one end closed pipe. So simply we can imagine this is one end open, one end closed pipe, and the length of this one is given to us, that is equal to 10 meters. So simply we can say this is 10 meters. Lowest frequency means the longest wavelength. So simply we can draw first of all the stationary wave inside this one. So this is how the stationary wave will look like. And if you look at this point is the node, and this point is the anti-node. So in this case, L is equal to lambda by 4. So simply we can say in this case lambda by 4, this is equal to L, and L is equal to 10 meters. So lambda is equal to 40 meters. We need to calculate frequency. So frequency is equal to V divided by lambda. Value of V is given, that is equal to 320 meters per second. Value of lambda is equal to 40. So we can simplify, we can cancel this 0 with this 0, so we got 8. So this one is the lowest frequency, so then for this question has to be B. So it's very important, question is asking you the lowest frequency. Question 27 says, in an experiment, water waves in a ripple tank are incident on a gap as shown in the figure. Some diffraction of the water waves is observed. Which change to the experiment would provide a better demonstration of diffraction? Mean how we can increase the amount of diffraction. For this one we need to understand there is a significant diffraction. You can simply say significant diffraction takes place. Significant diffraction takes place when lambda is about equal to the gap size. About equal to gap size, and if we keep on increasing lambda, diffraction will go on increasing. So this is the point we need to understand. If you look at this one, gap size, in this case gap size, this is much greater than lambda, so we have to bring them closer. So we have to increase the lambda. So if we increase lambda, it means gap size will be getting closer to the lambda, so diffraction will be maximum. So this is the main point, we have to increase lambda or we need to decrease this gap size, so they are almost equal to each other. Now if you look at given options, increase the amplitude of the waves, it has no effect on diffraction, so it has no effect, it will not increase diffraction. Increase the frequency of the waves, if we increase the frequency of the waves, it means lambda will go down. If lambda go down, lambda even gets smaller, so it means diffraction will go down. Increase the wavelength of the waves, yes, so this is possible answer. Increase the width of the gap, this will also minimize diffraction, so this will increase diffraction. So the answer for this question is C. So this is the main point you need to understand. When significant diffraction will take place, then lambda is about equal to gap size. Question 28 says, light of wavelength lambda is emitted from 2 point sources R and S and falls onto a distant screen. At point P on the screen, the light intensity is 0. What could explain the 0 intensity at P? 0 intensity means that there is dark fringe. So we can say dark fringe. So one simple way to say is dark fringe. It also means that destructive interference. So we can say destructive interference. And destructive interference between two waves takes place when they are anti-phase. When they are anti-phase, or we can say phase difference is equal to 180 degrees. So these are main points. Now if you look at given options, for option 8 is given to us, light from two sources is emitted 180 degree out of phase and path difference to P is 1/2. So this is 180 degrees phase difference, and this is also 180 degrees. So when they will reach at point P, it means these two waves, they will be in phase. It simply means that at this point they are in anti-phase, so we can say they are in anti-phase. But when they reach at this point, because the path difference is equal to lambda by 2, it means 180 degrees phase difference. So when they will reach at this point, these two waves, they will be in phase, so they will be constructive interference. So it means intensity will not be equal to 0. So option A is not correct. If you look at option B, it is given to us light from the two sources is emitted in phase. In phase, this is very important, and path difference is equal to lambda. So initially they are emitted in phase, so we can clear this one. So they are in phase here, and path difference is equal to lambda. It means phase difference is equal to 360 degrees. So when they will reach at this point, again they will be in phase. So this is also constructive interference. It means option B is also not possible answer. So this is incorrect. For part C, it is given to us light from the two sources is emitted 90 degrees out of phase, and path difference 2p is lambda. So here they have phase difference 90 degrees. If path difference is equal to lambda, means equal to 360 degrees phase difference. So here again phase difference will be 90 degrees. So interference will not be 100% destructive interference. So in this case intensity also will not be equal to 0. So this is also not possible answer. Light from the two sources is emitted in phase, and path difference is equal to lambda by 2, means the phase difference is 180 degrees. So here they are in phase, and at this point when these waves they will reach, they are 180 degree out of phase. So let me draw this bigger one. So they will be 180 degree. At this point they will be 180 degree out of phase. So we can draw they will be 180 degree out of phase. So in this case intensity will be equal to 0. Resultant intensity will be equal to 0. So the answer for this question is D. So this is how you need to figure out. Nice question, conceptual. Question 29 says a beam of red light of wavelength 720 nanometers is incident normally on a diffraction grating and produces a diffraction pattern on a screen placed parallel to the grating. The beam of red light is replaced with a beam of electromagnetic radiation of wavelength X, which is incident normally on the same diffraction grating. Same diffraction grating means that D is the same, means the slit separation is the same. The third order maximum for the electromagnetic radiation of wavelength X is at the same position, very important one, at the same position on the screen as the second order maximum for the red light. Same position, it means that angle is the same. So we can say theta is the same, position is the same. So theta same because it is given to us. Position same, so it means angle is the same. So if you have understood these 2 points, we have done this question. Now let me explain a little bit more. For diffraction grating, we need to understand d sine of theta. This is equal to n times lambda. For this question, it is given to us that d is the same for both of them and theta is the same, so it means sine of theta is also the same. So what does it mean? It means that product of n means the fringe order and lambda, this is constant for red light and also for X. So it means that n times r, lambda of r means the red light, this is equal to n of X times lambda of X. For this question, we need to find out lambda X. So we can say lambda X, this will be equal to n for red light times lambda of the red light divided by n for X. So n for r is given to us, so we have third order. This is for X, so this is third, and for the red is the second order. So we have 2 here and the wavelength of red light is given, that is 720 nanometers. We no need to change units, and nx, this is theory, so divided by this. Now if we simplify this one, we will get our final answer, that will be equal to 480 nanometers. So this is how you need to answer. I hope this question makes sense to you. And if this video was helpful, please like and subscribe, and also leave some comments in the comments section. And if you're looking for more help and extra resources, please join Patreon. See you next video.